Thank you everyone for coming. Really appreciate it. My name is Matt Weidner. I am a student here at CC. So here's just a quick introduction about me. So I've been studying JavaScript and full stack engineering here, but previously I was in the game industry for about 2 years. And before that, I was teaching English and working in pharmaceuticals prior to that. So I'm really excited to be here to talk about something I personally like a lot, which is inverse kinematics, and hopefully explain it at a higher level and kind of let you guys understand a bit more about what it is and why it's important and why we should think about it. Just more about me, I love the outdoors, I love soccer, and I love climbing. I also love games, so I hope we can share that interest today. So I want to start the talk off with just a have you ever question. And that question is, have you ever just kind of looked around at the world and appreciated it? You know, just kind of looked at the beauty around you and thought about the complexity of it and also the simplicity of it, and thought about maybe what that means to you as a person, and not just as a person, but as a human, and the way that we experience this world around us. I think this question is really important, especially when thinking about something like creating a new world. So game development involves the creation of new worlds. And there are just 3 little points here I kind of want to talk about you all with. So when we create a world, I think we all naturally inject a bit of ourselves into it. A bit of our own perceptions of reality, a bit of how we imagine things, a bit of how we view the world. And as we do that, I think it's important to remember that it's possible to share that perception. These aren't completely subjective. We can have objective ways of sharing our perceptions of the world, and mathematics is a way of doing this, right? More specifically, physics. So understanding physics and having that command of objective reasoning can really help to create these objectively believable situations that we can share with one another. So it's like, oh wait, I need math, yeah, about that kind of thing. I personally have not studied math seriously or intensively at any point in my life, but I've studied game development, and therefore I need math for that. So let's just do a quick dive into some things that might be useful for this talk. So mechanics, and more specifically, the mechanics we know in physics. So what are mechanics? You know, a branch of physical science that deals with energy forces and their effect on bodies. So by bodies, I'm talking about objects. And in a game world, you might think about models or characters or the things in your environment that you want to manipulate, right? And there are a couple of ways for us to do this. So has anyone heard of these vectors or scalars? Anyone familiar with these concepts? Yeah? Okay? Yeah? Okay. It's a quick definition of a scalar. So this would be a quantity that's fully described by a magnitude. So a numerical value alone, right? A number. Just a couple of examples of that. You might have kilometers per hour. If you're from where I'm from, that would be miles per hour. And time can also be considered a scalar value, believe it or not. A vector, on the other hand, would be that value along with a direction. So we can take kilometers per hour and tack on a direction to that, and suddenly we have a vector. So kilometers per hour east, 50 kilometers per hour east would therefore be a vector. And there are a number of things, you know, that build off of these concepts, like distance or displacement, perhaps velocity, acceleration, speed, all a combination of scalar quantities and vector quantities. And so then this kind of brings me to kinematics, and kinematics is the science of describing the motion of an object using a word or a diagram, perhaps numbers, graphs, or equations. And this is, you know, something that we all do every day, regardless of our understanding of physics or math or the sciences. That we have words we can do this easily with, such as stopped or slowing down, speeding up, turning. We have a vocabulary for this naturally. But obviously the aim here is to use kinematics as a branch of mechanics to develop a more sophisticated way of doing this, a more complex way of describing the world around us. The goal is to describe the motion of real-world objects. So with that said, I kind of want to do a little bit of an experiment, and you're all free to join in, or you can just watch me. I'll be doing it up here. And this experiment is really simple. So if you're holding something, you can put it down in front of you and kind of let your arms fall down to your side. Yeah, just like that. And then right in front of your face, within arm's reach, if you can imagine a ball just floating in front of you. And clear your head, and I want you to very simply reach out and grab that ball. Just like this. And then maybe return your hand down to your side. Just like that. Nice. Now, did anybody think about any of the concepts I just described while you were doing this? Anyone? Were you thinking about vectors or scalars, distance, displacement, any of those things? I think the answer is probably no. And the reason for that being that motion is unconscious. It's human. It's natural for us. We don't need to think about these higher concepts when we move in the world. But the problem is, when we try to map movement in a virtual world, we need to think of ways of translating this human unconscious movement into something very real and relatable in a virtual environment. But how do we do that without really intrinsically understanding what is going on in our own heads when we do something as simple as grab a ball? And people have devised a couple of ways of creating this motion, kind of simulating this motion in a believable way. Two of these concepts, kind of where the talk is going to go from now on, discussing these two concepts more specifically the latter concept, inverse kinematics, but forward kinematics and inverse kinematics and how they can help us to map motion. So I think we might be familiar with this picture if you know Elon Musk and the work he's done. But he has a factory with Tesla where he builds cars and he has robots that do this for him, right? And in each one of those robots might look something like this. So on this simple robotic arm, we have a couple of joints. Okay. We have a shoulder joint, we have an elbow joint, and we have a wrist joint. So the goal here is to kind of coordinate motion of these joints to allow this drill at the end to reach some end point where it can do its job, right? Where it can drill something. And if we were to approach that with a forward kinematics approach, we might do this kind of in this way. We might say, okay, let's move the shoulder. Let's focus on moving that shoulder. And in doing so, we'll move the hand closer to where it needs to be. And from there, we can make further adjustments with the elbow. We can adjust the elbow's height, we can lower the hand from the elbow. And finally, we might adjust the hand, and that might be a rotation, it might be a simple tweak. And the goal of that being, here's a little model I made in Maya to kind of like elaborate this point. The goal of that being that we achieve a motion. And that motion leads us to some place. So I'll play that one more time. You can see that we have a shoulder, an elbow, and a wrist joint here. So the first motion is from the shoulder. The second motion is from the elbow. The third motion is also from the shoulder. And then the final motion is going to be from the wrist. So this would be like a forward kinematic approach of moving a chain of nodes like this. So then what's inverse kinematics? Well, inverse kinematics is the opposite of that. So we would approach it in an inverse way. We would go from the hand, and then we would go to the elbow, and finally to the shoulder. So from this, it might be a bit difficult to imagine what I'm talking about here. But if you imagine a parent-child relationship here from the shoulder to the elbow to the hand, then any motion that occurs at the hand will influence the elbow. Any emotion that occurs from the hand and elbow will therefore influence the shoulder. And when you have a motion like this, the only real thing you need to be concerned with is the end position of the hand. The other nodes will position themselves accordingly. And I have a small GIF here that kind of illustrates that point. So you can see that the hand is being manipulated, and from that manipulation, the rest of the body is following suit and adjusting its position. Okay. But I mean, while robotics, obviously like IK is used in robotics, I'm more familiar with kind of animation side of things, so I kind of want to talk about that. In games, you'll find 3D animation, quite obviously, CGI. You'll also find motion capture technology being used. and a combination of those technologies as well. And obviously you'll find sprite animation, 2D animation being utilized in games. But IK probably is not going to be as important here. So if I'm going to talk about IK, I feel like I have to talk about this man, Alexander. He was the technical art director at a company called Ubisoft. I don't know if we're all familiar with that company, but he did some pretty amazing work with IK and combining IK with human motion capture rigs to create variable and very complex, yet at the same time simplistic skeletons for models in games. An example of that would be this octopus. He created this with human motion capture data and laid over an octopus model and was able to achieve animations without using FK. He used IK to create animations for that octopus. I have like a small video here from a talk he gave some time ago. I can just pull up the right scene. Here we go. So on the left side, just pause it real quick. Oop. Okay. So on the left side here, you'll see an FK rig. This blue man is an FK rig. On the right side, the yellow man is going to be an IK rig. And you'll notice the terrain is varied, right? This is randomly generated terrain. And so the goal here is to have these models respond accordingly to what they're encountering in this world, right? From an FK approach, as I talked about, animating down the chain, you'll have to account for, you'll have to kind of think about anything that your model might encounter, right? And animate accordingly for that. An IK approach is responsive. So if I play this clip, you'll kind of see that responsiveness occurring. Once again, FK on the left and IK on the right. Sorry about that. There we go. Okay, so yeah, you can see he's being quite responsive there with his terrain. And I can, there's another area of this that I think is quite interesting. Around this area here. Yeah, this really drives the point home, doesn't it? Yeah, none of these animations are pre-configured. This is all IK running in real time. Yeah, powerful stuff, truly. So you might think of reasons why we might consider IK in animation. So, I mean, you take a standard game and you have items that you're giving your characters. So you think, okay, in development, I want 50 items in this game, and I want each player character to be able to hold this item. So then the animator's job then is to, say, create 20 animations for each item, and then for each character. So the more items you have, the more work, the more time, the more cost. And those things rise and rise and rise and rise, right? And so then naturally you have a cap of how much work you can do. Whereas if you're using an IK approach, suddenly your character model is responsive. Suddenly it is not limiting you as a developer, as a designer, what you want to achieve. So if you want to, say, add in a bazooka, then go on ahead and add in that bazooka because your model is going to respond to it realistically and accordingly when you need it to. And, you know, this is obviously depending on the rules that you create for your IK rig. But at the end of the day, you can get these really interesting, responsive kind of scenarios that are believable and, you know, require very little work on the part of the developer. So yeah, with suddenly we're looking at the world differently now because the real world is full of scale, it's full of size, it's full of difference. And we often fail to achieve that when creating games. We attempt to mimic it, but it's a very hard thing to replicate. For example, I don't know if you know World of Warcraft, but you might have characters of varying heights, varying sizes, varying scale. And suddenly you have to match the running animation of all of them to the same speed. And what happens then is you have shorter characters running with inhuman strides to match the speed of the taller characters. And of course, you can tweak that. Perhaps on the side of the animator, you might be able to tweak that to make it more believable. But I mean, an IK solution would allow your character, your model, to adapt to changes in scale in believable ways. So some kind of downsides might be that it's quite hard to program. You know, a common technique would be the Jacobian inverse technique. I'm not familiar deeply with this technique, as it is incredibly complex. And you know, as a result of that complexity, it can be really rough on your hardware. So if you're trying to, you know, spread your game out into the market in a way that it's accessible to people with maybe lower spec hardware, that might be a challenge that you're going to encounter, especially if you're doing console development. But you know, it also might not fit with the style of the game that you're trying to create. So there's a lot of games out there that have these really unique stylistic attributes to them. And that is what keeps people coming back. Minecraft, you know, Pokemon, another. There's parts of Pokemon that we all love that they try deeply to maintain with each iteration, right? Sprite animation for fighting games. You know, these are all kind of things that we expect out of a certain genre. Mario as well. And Hearthstone or card games, you know, maybe 2D sprite animation on a 3D environment. Or Candy Crush. You know, none of these things require IK. You don't need it. But there might be times when IK is... Get this one. There might be times when you need IK to reach that level of realism, that level of believability that you want in the world that you've created. You know, because the goal here is to create a human experience. And IK can help make your world more visceral. You can help people to connect more deeply with the ideas you're trying to present them. You can drive immersion. I can see, you know, already IK being applied with VR in this way. For example, tracking the hands and having the arms move accordingly based on hand movements. That you can do this with motion capture as well, but IK is a much easier solution. And people are deriving simpler IK solutions like right now, every day. People are very motivated about this technology and trying hard to find ways to make it usable, applicable, to spread awareness. And if you're familiar with Unity, you know, you can use the asset store to find C# scripts there that people have written for IK. Maya has some inbuilt IK options. So yeah, I explored Maya a bit for IK, and I thought I would demonstrate some of what I created there for you guys today. Okay, so here's the arm that I made. I showed you in the slide earlier. It's a simple 3-jointed arm. And we're going to kind of do an FK approach to animating it right now. So I'm going to start at the parent, the elbow, right? And we're going to do a simple rotation on it. As I bring it up, you'll see the whole arm follows, right? I can do whatever I want with the arm. It's going to follow that parent mode and the motion that it makes. And if, you know, once I achieve a position there that I like, I might move down to the second or the first child and do a movement here. Right? So now we've got kind of an arm cocked gesture. And finally, I can kind of adjust the hand into a desired position. And then as an animator, I might say, all right, great, and snap a keyframe right at this moment. And then I'll kind of, you know, adjust it a bit more, snap another keyframe. That might be an approach toward FK animation that I could take as an animator. Conversely to that, IK animation, I think, you'll see is quite different. So if I take my IK right here, looks the same. I still have joints. I still have a shoulder, an elbow, and a wrist. The only difference is that I put an IK handle on here. And you'll see now that the range of motion comes from the lowest child in the chain, the hand. So any change I enact on this child here is going to perpetuate up through the chain to the shoulder. And I can do some pretty crazy stuff here really easily, really simply. So, I can just reach it all the way back here and get that full range of motion at the shoulder just from manipulating that hand, And I can go as crazy as I want with that. Get some punching motion there. Yeah, so really interesting stuff. And as a conclusion to that, things like VR and AR are coming. I think VR has been around for a while, but AR is coming out in a big way, as Julian is discussing across the room. But when you're developing AR, I think the biggest struggle that you're going to come across with is finding ways to kind of immerse yourself, not just in reality, but in what you've decided to overlay, right? Because that juxtaposition of what you've created and inserted and what you are used to observing all the time in reality can be very jarring. And it can be very hard to create something that is easy and believable, like in an AR setting. So we need to think of solutions for that. This is a time when I feel like coming up for a solution, it's a very exciting time for AR. And IK, I can see applications, but I don't want to just make this talk about touting how great IK is. I think that the idea is we need to be thinking of ways to make believable solutions in AR for this human-like experience that we want to translate into a virtual world, whether that be IK or something else. And I personally have been working on a game for the last week in C#, and this is just like a snapshot of it, but I would love to use IK in my game in conjunction with VR to create some fun experiences, and I think any developer can get excited about this technology. So thank you. I really appreciate everyone listening. I hope that was an enlightening topic.